All right, today we are jumping headfirst into a scientific detective story. And the mystery we're trying to solve, it's consciousness itself. We're going to be investigating a pretty radical theory that says our experience of the world, the feeling of being you, isn't just a trick of biology, but it's actually woven into the fabric of the universe, all thanks to the weird world of quantum mechanics. So, let's just get right to it. What is consciousness? I don't just mean what it does. I mean, why does all that electrical and chemical sloshing around in our skulls feel like something from the inside? This question, right here, is what philosophers call the hard problem, and it's a place where classical science just seems to hit a brick wall.
For a long, long time, the main idea was that the brain is basically just a wet computer, a squishy biological machine. In this view, our neurons are just fancy on-off switches, and consciousness is something that just kind of happens when you have enough of them. Maybe it's even just an illusion. But there's a rival theory that's been gaining some serious traction, the idea that the brain is more like a quantum orchestra, tapping into the fundamental laws of physics to literally play the music of our reality.
So our investigation really kicks off by asking why that simple computer model of the brain just doesn't feel right to a lot of scientists. There seems to be a ghost in the machine that pure computation can't seem to explain.
And this really is the heart of it all. See, we can put someone in a scanner and map exactly which parts of their brain light up when they see the color red. That's the so-called easy problem. But we have absolutely no explanation in classical physics for why you have the subjective experience of redness. That inner feeling, what philosophers call qualia, that's the real mystery.
Now, the first major clue in our case doesn't come from a biologist or a neurologist. Nope. It comes from one of the greatest mathematical physicists alive, Sir Roger Penrose. And his argument is based on the absolute limits of pure logic itself.
Penrose's argument starts with something called Gödel's incompleteness theorem. Now, to put it simply, what Gödel proved is that any computer program, no matter how powerful, will always have blind spots. There will always be certain mathematical truths that it can never prove, even though they're true. But here's the kicker. Human mathematicians can often look at those very same statements and, through a flash of insight, just see that they're true. So what does this tell us? Well, if our minds can do something that computers are fundamentally incapable of doing, then it follows that our brains can't be just classical computers. Penrose concluded that the mind must be using some kind of physical process that is non-computable, something that operates beyond the simple digital world of ones and zeros.
So, this mathematical clue points us directly toward our prime suspect, a very detailed and, I'll admit, pretty wild theory called orchestrated objective reduction, or Orch-OR for short. And it actually proposes a specific place and a specific way for quantum mechanics to be at work inside our brains.
According to this theory, consciousness is literally born from the collapse of something called quantum superposition. Penrose argues that when a particle is in superposition, meaning it's in multiple places at once, it's actually creating a tiny little blister in the very geometry of space-time. It's like two realities existing at the same time. And nature, well, it doesn't like that. The moment that blister becomes unstable and collapses back into a single state, that, he says, is a moment of proto-consciousness. So where on earth could all this be happening? The theory points its finger not at the big picture stuff like neurons firing, but deep inside them at the very scaffolding of the cell itself, these things called microtubules. It suggests these tiny protein cylinders act as little shielded quantum computers. The proteins inside them can pop into superposition, do some sort of calculation, and then their orchestrated collapse creates a unified moment of conscious experience. But just as we were zeroing in on our suspect, the case hit a massive, massive wall. For decades, a single, incredibly powerful argument seemed to give classical physics a completely unbreakable alibi.
Back in 2000, a physicist named Max Tegmark published a calculation that just seemed to demolish the entire theory. He argued that any quantum state inside the brain would be instantly destroyed by all the heat and noise, a process called decoherence. How instantly? We're talking 10 to the minus 13 seconds. That is unimaginably fast, less than a trillionth of a second.
The verdict was just damning. The brain is simply too warm, wet, and noisy to support the super delicate quantum states needed for this to work. The quantum effects would just vanish. Poof, billions of times faster than a neuron can even fire. And for most scientists, that was it. Case closed.
For nearly 20 years, the case went completely cold. The whole idea was pushed to the fringes of science.
But recently, a whole wave of new experimental evidence has forced investigators to reopen the file.
And it's been this rapid-fire series of amazing breakthroughs. Scientists have discovered that general anesthetics, the drugs that can selectively switch consciousness off and on, they seem to work by dampening quantum vibrations in those exact microtubules. In another incredible experiment, they even showed that if you stabilize the microtubules with a drug, rats actually become resistant to anesthesia.
I mean, these findings throw a huge wrench in the old wet computer model. You have to ask, why would anesthetics target quantum vibrations? Why would different isotopes of the gas xenon, which are chemically identical but have different quantum spins, have different anesthetic effects? And why does physically protecting the microtubule also protect consciousness? These are really, really tough questions to answer with just classical physics.
So, this huge wave of new evidence brings us right to the edge of a final verdict. Scientists have now designed what they think is a definitive experiment, a smoking gun that could finally settle the case once and for all.
Okay, so here's the proposed experiment, and it's brilliant. You grow little brain organoids in a lab, but you use heavier isotopes, which makes the microtubules physically heavier, but chemically identical. Now, classical theories would predict this change in mass should do nothing to the brain's electrical activity. But the Orch-OR theory makes a very bold, very specific prediction that heavier mass will cause the quantum state to collapse faster, leading to a measurable increase in the EEG's gamma frequency, a key electrical signature of conscious activity.
Just stop and think about what this would mean for a second. If that frequency actually shifts, it would be incredibly powerful evidence that consciousness is a feature of our biological hardware, not just the software running on it. It would imply that you could never upload a mind to a silicon computer because the very physical stuff our brain is made of is absolutely essential.
This leads to a completely radical way of seeing the brain. It's not just a machine processing data. It's a biological instrument, a finely tuned orchestra that has evolved over millions of years to resonate with the fundamental, proto-conscious properties of the universe itself.
And that leaves us with this final, truly mind-bending question. What if consciousness isn't something our brain produces at all? What if it's a fundamental property of reality, woven right into the fabric of space-time, and our brain is simply the incredibly complex antenna that has evolved to tune in and receive it? The verdict isn't in yet, but the case is more compelling than it has ever been.